So today we'll see LeetCode 3658 GCD of odd and even sums. So we will be given an n and we have to calculate the smallest n positive odd numbers and the smallest n positive even numbers, and we have to return the GCD of that. So suppose n is equal to 4. So what will be the sum of some odd? It will be the first four odd numbers, smallest odd numbers. So first four smallest odd numbers are 1, 3, 5 and 7. So the addition is 16, and the sum even is the sum of first four smallest even numbers. So first four smallest even numbers are 2, 4, 6 and 8. Addition will be 20. We have to calculate the GCD of both. So the GCD of 20, 16 will be, okay, so what is GCD first of all? So if I write the multiples of 20, that is the numbers that can divide 20. So 20 can be divided by 20 itself. 10 can divide 20. 6 can divide 20. No, sorry, 6 cannot divide. 4 can divide 20. 2 can divide 20 and 1 can divide 20. Similarly, 16 can be divided by 16 itself. It can be divided by 8. It can be divided by 4, 2 and 1. So what is GCD in that? So we have to see the common integers that can divide our numbers. So 1 is common, 2 is common, 4 is common. Rest all numbers are different. So we have to take the greatest. 4 is the highest number in. So the GCD of 20 and 16 is 4. So this is how you calculate the GCD of two numbers. So the first approach will be, so we have to firstly calculate sum odd and sum even. To calculate that, we can use a loop. We can use a loop to calculate sum even and sum odd. What we can do is, for I is equal to 1 to I n times 2, we can apply this loop and we can use this condition. If it's 0, then add it in even, plus equal to I, and if it's not even, that means it's odd, so we'll add it in odd. So we can calculate even sum and odd sum, and then we can get the GCD by applying another loop. We can apply a loop, a reverse loop. We'll firstly see which is the smaller number, and then we'll apply a loop in a reverse order and check if even modulus that number is equal to 0 and odd modulus I is equal to 0. If both these conditions are satisfied, we'll return that I. So that will be our GCD. So this is our first approach. The time complexity will be big O of n. So can we improve this? Yes, we can surely improve this. So our second approach will be to not apply loop to calculate sum odd and sum even. What we can do is, okay, so what will be the odd numbers? Let's write the odd numbers. So it will be 1, 3, 5, 7, and can I write like this, 2n minus 1? Let's check what will be the third odd number. Let's see, third odd number. So 2 times 3 minus 1, this will be 6 minus 1, that is 5. Is our third odd number 5? Yes, our third odd number is 5. So yes, our formula is working. So what will be our kth odd number? It will be 2k minus 1. So what we have to do is we have to add all the odd numbers from 1 to n. We have to add all the odd numbers from 1 to n. 2k minus 1. So let's do this. If we calculate this, it will be summation of k and minus summation of 1. Summation of k over n is 2 into n plus 1 divided by 2. Okay, this 2 is this. Minus summation of 1 is n. We'll cancel this 2. It will be n square plus n minus n. This n will be cancelled and our answer is n square. So we can directly calculate the sum odd by doing just n square. Let's check it. Suppose if n is given 4, so what are the 4 odd numbers? That are 1, 3, 5 and 7. This addition is 16. Let's do it directly by n square. 4 square is 16. Yes, they both are matching. So yes, we can directly get sum odd by just doing n square. Now let's derive the formula for sum even. Let's write the even numbers. 2, 4, 6. 2 times n. Can I say that 2 times n? Let's see what is the second odd number. So we'll do 2 times 2, that is 4. Is 4 our second odd number? Yes, 4 is our second odd number. So what will be our even number? Kth even number will be 2k. Let's apply the same formula for all the even numbers from 1 to n, 2k. So 2 will be removed, 2 will be taken out, and we'll apply the formula on k. So it will become 2 into n plus 1 by 2. 2 and 2 cancel. It is n square plus n. N square plus n. This is the case for even. Let's check it. Is it correct or not? So what is the sum of first 4 even numbers? It will be 2 plus 4 plus 6 plus 8. It is 20. Let's check if is it 20 or not. N square plus n. 4 square plus 4 is 16 plus 4 and it is 20. So we directly got the answer with using the formula. So now we can directly calculate sum odd using n square and sum even by n square plus n. Now what about the GCD? This is can be calculated using Euclidean method. Now what is Euclidean method? I'll directly write the function. Suppose I get two integers a comma b. I have to calculate the GCD of them. So I'll apply recursion. GCD a modulus b and b. You calculate this, and as soon as I get here 0, if I get a is equal to 0, what I have to do is return b. So this is our answer. This is called Euclidean method, and the time complexity of this function is log of minimum of a comma b. So our overall time complexity will be, to calculate this sum even and sum odd, the time complexity is big of 1, and the time complexity to calculate this is log of minimum of a comma b. So overall time complexity is this. Now let's go to the third approach. And the third approach is very fun because we can solve this question just by one line code. Just one line. So let's derive how do we solve this. So the sum, what we have to do basically, we have to do GCD of sum even and sum odd, right? You have to calculate the sum GCD of sum even and sum odd. So let's apply the formula sum even is n square comma n square plus n, right? So now let's write it like this. It is n into n comma, let's take n common, so it becomes n plus 1. Now since both the numbers have same multiple n, we can take it outside the GCD, so it becomes n times the GCD of n comma n plus 1. Now we have to calculate what? The GCD of n and the next consecutive number. It's like this: GCD of 7 comma 8, GCD of 102 comma 103, like this, the next consecutive number. And the GCD of two consecutive numbers is always 1, because two consecutive numbers are always co-prime numbers. Okay, so the GCD of consecutive numbers are 1. We can see an example. Suppose we take 7 comma 8. What are the multiples of 7? It is 7 and 1. For 8 it's 8, 4, 2 and 1. The GCD is 1. We can clearly see that. So yeah, the GCD of two consecutive numbers are always 1. So it becomes n multiplied by 1. But we were calculating the answer. Answer was the GCD of our sum even and sum odd, and the answer is n. So what it says, we have to only write return n, and our question is solved. The time complexity is obviously big of 1. If you have any doubt, you can ask in comments.